Meanwhile, back to the hunt for the solar system's most likely venue for alien life. Maggie's been talking to Leigh Fletcher about ESA's upcoming JUICE mission to the icy moons of Jupiter.
Hi Leigh, lovely to speak to you again. And I wanted to get the ball rolling by talking about the discovery of phosphine in the atmosphere of Venus. I'd love to get your views. Do you think it's an indicator of life?
I'm not entirely convinced just yet. I think there's so much we don't fully understand about the chemistry of the atmosphere, the interaction with the surface, and the volcanism that might be taking place on that world. But I'm prepared to be astonished and prepared to be amazed.
Where else in the solar system do you think we should be looking?
I personally believe that the best place to go to look for evidence of habitable conditions are the icy moons of the outer solar system. Somewhere like Europa, for example, the moon of Jupiter that's tantalised us for generations. Now, we've been searching for evidence of liquid water across the solar system, and Europa has it in spades, probably twice as much liquid water on Europa as there is in all of the oceans on planet Earth itself. And compare that with somewhere like Mars, where we've been continually searching for evidence of liquid water, and it's been very hard. Europa, Enceladus, Ganymede, and all of the rest of those icy satellites, I think, are the places to go to look for evidence of habitability.
Speaking of Enceladus, the fact that Cassini found all that water and also jets spurting out into space, is that a game changer in terms of where we look for life?
I think the really important thing about Enceladus was how we didn't expect this tiny little icy moon of Saturn to be quite as interesting as it was. It had these fissures located on the South Pole with these geysers of liquid and gaseous material coming out from the interior. That's where nature truly is conspiring to give you access to the material that's on the inside. And that's the holy grail for us. We want to sample the conditions, the material, the chemical composition of those deep, dark, hidden oceans.
So what is happening in terms of research out there? And can you tell us more about JUICE, a mission you're working on?
So the JUICE mission, the Jupiter Icy Moons Explorer, we're only about 20 months away from the launch of this mission, which is quite an incredible thing to think about. And ultimately, it's going to be the first ever spacecraft to go into orbit around an icy satellite, Ganymede, the largest moon in our solar system. Now, the key goal of JUICE is to understand the emergence of potentially habitable environments around gas giant planets, to extend what we might traditionally think of as the habitable zone out beyond the confines of the Earth and the terrestrial planets into the more distant, cold, icy realms of the solar system. Because there, instead of sunlight providing you with that energy source you need to keep water in a liquid phase, instead you have tidal heating. The moons of Jupiter and Saturn are constantly being flexed and kneaded by the powerful gravitational field of the gas giant itself, and it's sufficient to keep the insides of these satellites as hidden oceans of liquid water.
You mentioned that JUICE is 20 months away from launch, and I think it's going to take over 7 years to get there. But when it does and it starts getting data, what would be your hip hip hooray moment? What would you like it to discover?
I think that potentially the most exciting instrument we've got on board is an ice-penetrating radar. And what that's going to be doing is sampling the subsurface of these icy moons, down to potentially depths of about 10 kilometres below the surface itself. Now that means we've got the tantalising prospect of mapping the interface between the watery ocean and the icy crust itself, and potentially detecting things like subsurface pockets of water that might be feeding those plumes themselves. So I think in just over 10 years' time, when JUICE is orbiting Jupiter and taking these wonderful observations of the icy satellites, it'll be those subsurface measurements that I'm particularly excited about seeing.